Welcome back. This is part 2 of the lecture for Thursday, January 30th, 2014, CIST 1400. Before we move on to talk about the character class, I want to do a real quick update of operator precedence now that we have the negation operator, that exclamation point, and also our logical ands and ors. So this is the this is what our operator precedence looks like now. Okay. We can classify by type pretty easily. Okay, so with our parentheses, that's not going to change the type at all. With the unary prefix, that's going to always result in a Boolean, but it also takes a Boolean. So we keep the type there. With multiplication and addition, so far we've only talked about the numeric types, and very specifically we've only talked about integers with regard to the numeric types. And so our multiplication and addition, or multiplicative and additive operators, are going to result in an integer so long as we feed them integers. Then we've got the Boolean operators, right? The relational operators, the greater than, less than, greater than or equal to, less than or equal to. The equality operators, that equal to, not equal to. And then after that, after all of those are resolved, and we only have like true and false values, we deal with our logical ands, and then our logical ors. And then finally, we deal with assignment, if it exists, whatever that assignment might be. So that's ultimately how that all shakes out. Okay, and this is, and by and large, this ends up being fairly intuitive when you're working this out by hand. We deal with the parentheses first. We have to do our math before we can do any of these comparisons. And we have to do these comparisons before we can do any of our operators with logical and or the logical or. And we have to get everything resolved before we can do any of the assignments. Alright. So a couple of common logical operator errors. The biggest one is probably those mutually exclusive AND conditions. If you have something like a number that is less than 0 and a number and that same number is greater than 100, that's a thing that'll get you in trouble. And that's a mistake that you'll make, and it's a mistake that you'll see me make, and that's all right. It's pretty easy to fix once you see it. It's just the compiler will not tell you that that's the case, and you might end up having some really weird errors for a bit. The next logical operator error that you'll probably see is just putting your parentheses in the incorrect places. Having too many, having too few, having them not quite match up exactly what you want. That's a thing where you can just mostly, it's a matter of paying attention in Vim. The third error that you'll probably see is having overly long statements, right? If your if condition, if your logical operator condition, if they end up being too terribly long, if they end up being more than 5 or 6 simple conditions, or maybe just 2 or 3 complex conditions, it ends up being sort of hard to track and hard to edit and hard to look at. So the thing that I'll suggest is using something like a Boolean flag technique, like we talked about before, to keep track of particularly complicated decisions. Or later, and when I say later, I mean a little bit after. Not too long from now, we can also abstract that away into a method that returns a Boolean value. And we'll talk about that more here in a bit, in a couple of weeks. The last logical operator error that you'll probably see is forgetting operator precedence. That is to say, evaluating the logical or before the and, which is incorrect. The and always comes before the or. We go from most restrictive to least restrictive. And that's just... Those are all errors that are pretty easy to fix. Just some of them are sometimes difficult to find. So we're going to introduce a new type of primitive here, and this primitive is called the character, which we in Java abbreviate as the char. Okay, so it holds a single character, a single letter, a number, or a symbol, and it holds them between single quotes. Remember, with a string you have double quotes; with a character you have single quotes. That's how we know that it's a character. And the character is represented internally as just a number, whereas the string is represented internally as an array of characters. And that'll mean more in a while, here in probably in about March. With the character, just got those single quotes. The string, which is more than one letter, more than one number, more than one symbol, it's going to have this double quotes. And so we get chars from strings using the strings.char at n method, where n is some integer between 0 and that string's length minus 1. And we'll talk more about the significance of those numbers also when we talk about arrays. So for example, let's say we have this string called text, which is says here is some text. Okay, now this is 18 characters long, counting white space. The very first character is going to be at index 0. The second one is at index 1. The third is at index 2, index 3, index 4, index 5, all the way to index 17. Okay, now if we try to go to index 18, we'll get an index out of bounds exception. That'll crash our program. But all the way to index 17, which will be that last T. And when we want, so this is sort of useful, but when we want to get a character from the user, we can do so by appending, well first by getting a string, which you can call word, using the .next method. And then hopefully that string is only a letter long, but it's hard to say. And then from that, using the .char at 0 to get the very first letter of that string, and then we can put it into a character called letter. That's a thing that we can do. We can also combine these if we want to. This particular line of code, these lines of code do the exact same thing as the previous lines of code. We make a scanner, and then this char letter is equal to sc, which is the name of our scanner, .next, that gives us a string, .char at 0, which takes the first letter of the string. Okay, so we have our variable, that char letter, that's just our declaration. That sc.next, that collects the string using our scanner. And then the .char at 0 is the first character of the string. And all these dots that you see chained together, these are called dot operators. Okay? Now what that means is that you just have, we take whatever the result of the previous thing is, and we do something to it, right? So in this case, .next, or more specifically, the commands of the things previous. So .next tells the scanner to give us a string, and then .char at 0 tells that string to give us the character at position 0. So the one at the very end, that's the one that's going to be your result. Okay, so these just go sort of in logical order. We get a string, then we get the character. Let's do just a little bit of playing with characters. Okay, so we have this char demo.java. I'm going to open that up. There's not much in here just yet. Okay, so system.out.print, give me a letter. Okay, and then we're just going to use that method that we saw before. That char letter is equal to sc.next, that gives us a string, .char at 0. System.out.println. Actually, we'll make this a printf. Your letter was, and then we can go to %c. That's just the format sequence for a character. Make a few more new lines. Close that. Then letter. Okay. Now this is just going to take the very first letter of the word that we input and input it and store it inside a char called letter. Okay, now that char is always going to be a single letter no matter what. We're going to save and quit. See if we have any errors. Everything's good. When we run this, let's say give me a letter. Let's give it a B, let's say. In this case your letter is B, so that's alright. And then we can try it with an L, and that's good. Now what happens, I suppose, if we give it more than one letter? Does that crash things? Does it break anything? So we'll give it an ABC. And in this case, our letter was A. Okay? And that's because we take this whole thing as a string and then take the very first letter using that .char at method. And this caret ::d, I think that is that's one of the other keys. that I hit by accident. So it might be an up key that I accidentally hit. You can find out for certain. Yeah, it's the left arrow. That's what I actually hit. So those are things that we also might work on. But yeah, so when we run this program, we end up seeing that we can use .next.char0 attached to our scanner in order to get the first letter of the user's input. And in this course, generally, when you ask the user to input a letter, and by generally I mean all the time, when you ask the user to input a letter, they'll input a letter. That'll happen every single time. This does, though, open up some interesting properties of the scanner class, which we're going to talk about here. Now the scanner objects each have a buffer, and a buffer is just a storage place for for putting tokens, and we call tokens it's just like alphanumeric and symbolic text. And so this gives us a couple of interesting options. So for example, instead of collecting input items one at a time, we can collect them all at once, so to speak. We're still collecting them one at a time. We just hide the one at a time part. So if we wanted to, we could do something like enter a number and then store that as a number using .nextInt, and then enter another number and we store that also using .nextInt. We could do things like that if we wanted to. The other way that we could go about it, if we felt so inclined, is we could tell the user, hey, enter 4 numbers. Collect the first one, collect the second one, collect the third one, collect the fourth one. And that'll all work out just fine. So suppose that we enter an 8765. Right, suppose that that's how we go. And I apologize, the formatting on this slide went all screwy. This is just num1, num2, down below there's a num3, then a num4, using the in.nextInt. So the first one, this is where I want you to really look, this blue box, this is where your buffer is. So we've got an 8765, and the 8 is the first thing in our buffer, so the .nextInt calls it out, checks to see if it's an integer, and then if it is, stores it in num1, and if it's not, we crash our program. Then it gets cleared out. So now we have a 765 in our buffer. We get the 7 using .nextInt, that gets stored as num2. Then a 65, and then a 5, and then our buffer is empty. And if our buffer is empty, then we just have to, then what Java will do is it'll block the program. It'll wait until we input another token before proceeding. Okay, and so so generally the way this works is we can separate different things with white space. We can make them white space delimited. And a white space is just spaces, tabs. In this case, it's just spaces and tabs. So you collect the next token, which is just a chunk of characters that aren't white space. Then test that token against whatever method we want to see if it fits. So if we're collecting an integer, we might test it against .nextInt. And so let's say you wanted to collect an integer, a word, and a character in that order, all separated by spaces, something like 8272 banana q. We could do so like this, right? So we prompt the user, we collect our integer, like the user inputs everything that hits enter. We collect our integer, now the next thing is our string. We collect our string, now the next thing is our character. We collect that character. So we can do that if we want to. We can collect multiple things with a scanner all at once by relying on the scanner's buffer. The thing that we have to make sure of, though, is that everything is separated by spaces like we have here, right? So we have our integer, then a space, or lots and lots and lots of spaces, then a string, then one or more spaces, then our character. That's the thing that we have to make sure we do. We also have to make sure that we tell the user exactly what sort of information we want and exactly how we want them to input that information. And in this class, you can trust that your user will follow that. And I'll specify for you exactly how that information should be collected in subsequent classes and in your professional careers. You'll have a whole series of techniques that you can use to very precisely control exactly the type of information that your user gives you, which is to say that you'll be able to write software where if you're asking for a number, for example, your software will not allow the user to input anything other than a number. Or if you're asking for, say, an email address, your software will not allow the user to input anything other than a valid email address. Or at least an email address that fits some specifications, and that's and that's stuff that you'll get into in the future. When we come back, we're going to talk about the switch statement, which is a fancy way of writing some if-else statements, or it's a simpler way. See you in a second.